Hey everybody, happy Thursday. Hope you're doing well. Let's cut this down here. Alrighty, we got a couple things today. So first, we're talking about Project 1. I think everyone got a chance to get that one in. Right, it was due today by 3:30. And then we're going to finish up our chapter here on loops. So we're going to look at another kind of loop we haven't gotten to yet. So I'm going to leave this loops project here alone. I'm going to start up a new project for Project 1. And we'll work on that. So we'll call this Project 1. I'm going to do it in a new window. I'm going to leave both PyCharms open so I can come back to the other one real easy. And let's take a look at our project here. Make sure we're getting everything right. Let's see. Yep, so just a very basic retirement calculator here. Just some basic values, and then we'll apply some basic formulas to it. Again, this was not the most complicated project. I mean, we're doing, basically much stuff in our labs at this point, but, we got to start somewhere, and then we'll ramp up as we go. All right. Sorry, put that on quiet here. So there it goes. All right. So we needed to ask the user for their name, and we're going to use their name in all the following prompts. So that's the first thing. So we can go get their name. So we'll say name equals an input of, please enter your name. Okay, and then we can start asking for all the rest of the information. So we'll have our, what do we call it, the cash savings, right? Or how much money they have saved underneath their mattress. Okay, so sure. So money under the mattress is an int of an input. It probably didn't tell us how many pennies, but I guess we could make it a float just in case, right? Because sometimes you have change underneath your mattress. There are 2 T's in mattress, is that why? There we go. How much money do you have saved under your mattress? Okay, and we're just going to keep on repeating this then for the bank savings, bonds, and stocks. This is then bank savings. This will be our bonds, and this will be our stocks. Right, so saved in your bank. How much money do you have saved in bonds, and how much money do you have saved in stocks? Right, so we'll get those initial values. Oh, but we're not using their name, right? So we need to make sure we're using their name here. So it's name plus here to append those strings together here, right? We're not printing, so we can't just comma separate. So we need to do this string appending here. So we're using their name in all the prompts. Cool. So we got their name, we're asking how much money they have saved, asking for their age and what age they wish to retire. All right, I'll come back to this one. This will have current age is ask for their name. So it's probably an integer, right? They're probably not giving that in a particular kind of value here. We'll say, how old are you? Okay, and then we'll ask for the retirement age. Retirement age, int of an input. How old do you to be when you retire? Okay, cool. I know, always fun to think about retiring, like when you're still here in your college career, but you got to plan ahead, right? And you'll see the power of compound interest is fantastic. Right, and we're going to calculate the total value of their savings in the year that they retire. So this one doesn't increase. This one gets multiplied by 1.01 to the number of years, 1.02 to the number of years, 1.1 to the number of years. Display the value of each type, and then calculate the present value. So we're getting there. We got these ones. So then we need to figure out years until retirement. Right, that's a pretty simple retirement age. Retirement age minus the current age. Okay, and then we need to change the value of all of these, all the savings here. So the money under the mattress doesn't change. The bank savings then will be multiplied by, so times equals, if we want that shortcut, 1.01 to the years until retirement for a little shortcut for exponential. So we'll get whatever that value is here, times the current bank savings, applied back to itself. We'll do our bonds, we said was times equal 1.02 times the, to the power of the years until retirement. And stocks is going to be 1.1 to the years until retirement. And then we can print out the current value. So print when you retire, your money under the mattress will be worth, and all right, let's see. Well, this one we can, we put a $sign and then comma separate. And we did want these nicely formatted. So now this one's not going to change. There's no formatting that has to happen here. But if we do that formatted string, right, while we're here already, I can just say, okay, here's my variable for it, money under the mattress. And then we'll format it here, right, point to F to make sure we get our that. And we want the comma separated values, make it look pretty. And the comma separation wasn't required, but right, and we just get a repeat then, right, for money in bank savings will be worth, and this is our bank savings value then. Right, we got to format them all the same. Hey, thanks so much for following along. Glad to have you here. And then our money in bonds will be worth the bonds value, and the money in stocks will be worth, again, gross oversimplification. It doesn't actually work like this, but that's okay. Right, so then we need a total. Right, so then total savings will be the mattress money. What is it? Money. Come on. Money under. Come on, type ahead. Give me the type ahead. There you go. Money under the mattress plus the bank savings plus the bonds plus the stocks. Right, and we can print your total. And probably here we'll just probably do a nicely formatted one here too, right? So your total savings will be worth, here's the total savings. Again, doing the formatting because we get some funky decimal places with some of that arithmetic here. And then we need to adjust for inflation. So the total savings, we need to divide by 1.03 to the number of years to the retirement, right? So if money is worth 3% less every year, we need to find out how much less our money's worth. And this might be slightly incorrect. I can never remember the actual math, whether or not we need to divide by 1.03 to the number of years, or if we need to multiply by 0.97 times the number of years. I forget exactly how that works. Because it's compounding. I think it compounds both, but the math works out a little bit different, right? So like, I don't know, that's fine. Not all that important. We'll go with this because that's what I asked for, but may or may not be exactly correct. So we'll divide equal by 1.03 to the power of years until retirement. Then we'll print, sure, basically, and we can say the present value, or no, did I say the future value, right? Future value of your savings is worth total savings. Is that the right term? Present value. That's right. So present value. So because even though you're going to have like 3 million in retirement in the future, it's only worth so much in today's purchasing power. We need to think about that when we do our calculations as well. All right, so let's take a look compared to the rubric here. So we use their name, use it in the following prompts. Let's see if we did that. Following prompts. So sure, we can add their name. So these ones aren't prompts. They're not asking for any information. Typically a prompt is like, hey, give me something. So if you didn't include it in the bottom one's great. If you did include it, that's fantastic too. We could put it in here right away. Right? It's just name, comma. But it's nice when we're already doing these formatted strings here. It's a string interpolation. It's fantastic. Such a nice little shortcut here with these formatted strings. Do that here, and name, present value. Okay, let's give it a shot. We'll run. Throw, we'll say Eric. Let's just do this. We'll put $100 in each for now, just to see if the math is doing something here. And we'll say I'm 34. If we retire at 70, right? So the money in the mattress doesn't change. Money in the bank goes up a little bit, right? 43% over, is that 36 years, right? Sure. Bonds went up even more. Stocks went up way more, right? 10% is huge over 34 years. Total value, and then, but oh, bummer, that's only actually worth about 1,200 today. Right, so every year that inflation eats away at what you're actually returning in terms of the future value of money. And now again, hopefully some things do get cheaper, and not everything will go up in price all the time. Like if we get better at agriculture and sort of commercial farming and whatever that sort of stuff is, maybe it'll be cheaper for food because we've figured out how to 3D print our food or some sort of nonsense in the future. But essentially, we need to calculate and adjust for that. All right, questions, thoughts, concerns? Your good folks are quiet in chat today. That's okay. So he's actually even around. Yeah, a couple people around in chat. Cool. How'd this one go? Hopefully this was pretty straightforward here. All good? Awesome. Great. Yeah, again, not the most complex project, but again, we had to start somewhere. And this was, we assume your first programming course. You might have had some previous programming experience. In that case, you're bored. I apologize. But we'll be ramping up as we go. We're getting there. All right, so let me commit this to GitHub here. And we'll get that saved, published out there if you want it for reference. And we'll talk more about loops. And then we need to talk about the next project as well. That's right. Now that we have covered loops, we can talk about our next project. We'll do 1501 for fall. This is project 1. Project, put the letter P in there, project 1. And great. Commit and push. Typically we'll have projects every 2 weeks or so. Now that we've done enough here, not courses, I want our syllabus. Find that over here. There we go. All right, so we're doing loops. We'll have 2 weeks. We'll do a project due by this week. We won't pick one up right away because we got the midterm coming up. But then we'll pick up a project after the midterm. I think it's probably better here. So this will be doing 2 weeks on the 21st. And then we'll do the midterm on the 25th. Right, at least that way the project's done and out of the way. Focus on the midterm. It's a couple days if you need to. And then we'll pick up the next project after that. This coming week. We'll do that for 2 weeks. Have one more project. We got our final project. Ideally, we'll talk about it on the 16th for the final project. So we've got enough time to work on it. I think once we've done files, we should be good for that final project. So we do one to this week, one to this week. Yep. Yeah, John, it's actually an online interactive textbook. It's through our friends at Zybooks. The Python programming Zybook. Alrighty, so let me close this one down and we'll pick it back up here with our loops. We left off at 5.5. That was talking about our next kind of loop here. Is called a for loop. So these are all while loops. We did if something's true, we'll run the loop. At the end of the loop, we check. If it's true, run it again. If it's true, run it again. If it's true, we run it again. We keep on going. Okay, so a for loop is different. It doesn't run as long as something is true. A for loop is used to loop over a container. Right, we've talked about we have a bunch of different container types. So if I had a, let's say we had some sort of names list here. Right, we said, okay, I've got Eric, Jasmine, Joy, Deb, Phoebe, Journey, Jubilee, and Jack. Here we go. Here's my family. Oh, I can throw John in there too. Sure, you can. You're an honorary family member now, John. Okay, so right now all we've really done with loops is I get things out by index. I could say, okay, names at index 0 is the first item. Sure, names at index 1 is the next item. 2, 3, 4, on and on and on and on. We can get at those items individually one at a time. We can append to it, right? Names.append. We can add something to the list. Remember, a list is mutable. It's flexible. You can add and subtract from it. You can remove from it. But we can't do things really one at a time yet. So we're going to introduce the for loop. So we're going to say for. Now, this is where it gets a little funny here. So a for loop allows you to give a name to the item we're currently iterating over. Right? This idea of iterating is we're taking one, going to the next 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 one. We're just iterating over this collection until we've gone from beginning to end. So we'll say for name in names, and then a colon. So name is my variable name for the individual name in the names list as we iterate. Okay, so then what I can do is I can print the name. Right, name is the variable. Not a very interesting one here, so let me actually put this up at the top. I'm sorry. So put a note here. We're jumping around. So this is 5.5. So that way I can just stop. We don't have to do the rest of our stuff here. Oops, we need that names list. Forgot my copy paste. Okay, so it'll print each name individually in that names list. Okay, one at a time, one per line. Vivi is actually Genevieve with a J, so all the kids have J names because Jasmine's the 3rd generation of J names. So all of our kids are the 4th generation of J names. And John, you just happen to fit, so lucky you. I guess we can keep you. They keep trying to convince me to change my name to Jarek, but I'm not so sure. Yeah, so you get names, at index of 0, at index of 5, index of 7, right? Whatever position you want, where 0 is the first one. Nope, it doesn't detect the length. Nope. So if we say names, remember, like index of 10, I'm going to print that out. There is no 10th index, right? We have 9 items here, so we have indexes 0 through 8. So if we try and print names at index 10, yeah, stop and rerun, thank you. Stop. There we go. List index out of range, and it crashes. It's not a valid index. No good here. The for loop is just going to take one item at a time. It doesn't even get items out by index. Now, what's fun about for loops, right, is that we can loop over other things as well. So we could say, hey, how about we take, I don't know, let's do, let's write the alphabet. Right? We did one of these for our quiz exercises where we said, okay, it's A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And we said, okay, let's by index get out your name here. But what we could also do is we could loop. We could say for letter in alphabet. Remember, because strings are sequence types. Print the letter. Right? So we'll get A, B, C, D, E, F, G. We'll get them all the way back out here, one letter at a time. Yeah, for loops are different in Python, John. They're iterators over a collection. We can get the alphabet out. Again, still not super interesting right now, but remember, strings are sequence types. They're containers, essentially. It's just a bunch of individual characters, one at a time, so we can print them out. Now, remember we talked about strings being immutable, and you can't change the value of a string. Now I can reassign to it. Yeah, trumpet, yeah, it's definitely. So it's making a temporary variable. Yep. So we could do the exact same thing with a for loop, right? Or with a while loop. I could say, I want in index value to be 0, and I can say while index is less than the length of the alphabet, print the alphabet index of the index variable here, and then when we're done, we'll take index plus plus. I'm sorry, plus equals 1. Sorry, that shortcut's not available. Python's weird. Yeah, it's a handy loop there, John, for sure. So we could do the exact same thing here with a while loop, right? If we know the length of the alphabet, right, we can get at things by index, which is fine, okay? So if strings are immutable, right, when we loop through names, what's going to happen if I say name equals name dot upper, right? If I want to uppercase all the names. Here, let's take name, assign it to name uppercase, so uppercase the name, assign it back to name, print the name out. Right? We're going to get all uppercase names, right? We're going to just stop and scream here at you, apparently. Okay, my stop is not working well. There it goes. Stop. So we get all uppercase names. But now if I were to print the names collection, the names list, are all the names going to be in uppercase in my names list here? Because names are immutable. I'm sorry, strings, not names. Strings are immutable. You can't change the string where it exists in memory, but you can assign it to a new string and a new location in memory. So when I say name equals name.upper, it's making a new string in memory as an uppercase version and saying, oh, name, now you point here. Hey, Dodo, how you doing? So what's going to happen is the names are not changed in the list, because name was a temporary holding place, right? This was a temporary variable here. So if we did that loop again, we said like while, or we wanted index equals 0 again, while index is less than the length of names, right? You can get the length of a list just like you can get the length of a string, right? We could say you want to take name is equal to my names at index of the index, and we'll take name.upper, and we'll print name, and we'll take index plus equals 1. Oh, fantastic. Good to hear, Dodo. I imagine you've got to be pretty bored, right? Because you know a little bit about programming already? Oh, awesome. Good to hear it. Oh, my stop is not actually stopping. Here we go. So it prints out, again, another uppercase version here, but it's not changing it inside the list. Remember, when you pull something out, we're saying, okay, sure, you are pointed at this location in memory, but when we reassign it here, we're no longer pointed to that item in the list. And I found out the whiteboard actually like slows my computer down here. There's a free book you can get instead, a free Python book, John, that I would recommend. The Zybooks has a really cool interactive feature where you can like practice some of the things, but it's Python for everyone. I forget the actual link here. Let's see. 3 lectures a week plus 2 labs. Wow. Oh yeah, Python. Oh, PY for everyone. There we go. PY for everybody. So this was actually written by one of the profs over at U of M Ann Arbor at the School of Information, Dr. Chuck. So I would recommend this one as a free resource here for sure. It's not quite as cool as our Zybook, but it's really cool. Still pretty good. And you can actually get the certificate. U of M Dearborn students are U of M students if you really want a certificate for whatever reason here. But you know, we're already taking a Python class, so but that's a good resource. Got lots of good stuff there. We can actually close that down. All right, so remember when we make this list here, we say, okay, I want a list. I want to store a string somewhere. Right? What we're actually storing here is the memory address, like 7234 of that string, and somewhere out in memory, then it says Eric. Right? We don't store the string directly in the list because a string is, hey, this is where I am in memory. So we store the memory address. And like x23fb is over here. We'll say Jasmine. Okay. So when we loop through and we say, all right, I want name is equal to the names at index. Right, those are square braces here, not parentheses. It says, okay, name, you are x7324, right? And that points over here. And when we say name equals name.upper, it can't change the string here in memory. It's immutable. It's immutable. Yeah, O'Reilly's really good, nice. They've got, is that Books 24/7 or something? I forget what they call it nowadays. They've got a ton of resources. And I think we have access to that too through our library, I want to say. I have to look again. So like basically any tech book, and O'Reilly writes like a lot of textbooks, we've got free access to, which is really cool. So name.upper will make a new string, say like 3fb9 with Eric here. And now name doesn't point to here anymore. We say name, hey, you now go point here. So I've not really changed name. I've changed the value, or changed that I was pointing at. I made a new string in memory and said, okay, now I point here. So changing that variable inside the loop, whether or not it's a for loop or the while loop, we're not changing it inside the list, right? If we wanted to change it inside the list, we need to change what's stored at the index, and that we can do, right? So if we wanted to, we could just work just with names at index. So to change it, let me just make a copy here. Oops, that didn't tab in right. So instead of doing any of that, we're going to take names of index equals names at index dot upper. So take that value at the index, uppercase it, and then store it back into the list. So this is actually changing the list. Right? This one doesn't change the list. It's changing my variable. So now, this third time around, not print name, we want to print names at index, we'll get the uppercase version, and we'll store it. Yeah, stop and rerun. Yeah, actually kill it, please. And we'll see our list has actually been uppercased because we've now modified the list. So for loops, you do need to be careful. With values that are immutable, you can't change them. So that's the big takeaway here. So a for loop can't actually modify immutable values inside a list. You can change the list if you want, though. Right? Perfectly fine to do that. So just be careful with our for loops, right? They're a little bit tricky here when it comes to that. Now, there's lots of any sequence type, right? Any lists, tuples. You can iterate over a dictionary too, which is fun. So if we had that dictionary, right? We said, make much more space here. So if I had a bunch of classes, right, equals a dictionary of, and okay, we had CIS 1501 colon CS1 for data science or scientists. Data scientist, I don't know, data science, I forget exactly what it's called. I really should probably know what my course is called. That's a little sad here. And we have 2001 colon, which is CS2 for data science. I could go look it up if I really wanted to, but that's okay. And then we had another class in here. Oops, let me put my comment down here. Come on, stop yelling at me for my format. Stop. And we had CIS, what is it, 3500 or something. Data scientist. Data scientists. Okay, scientists. There's no C. Scientists. Okay. English is not my strong suit. I apologize. 3500, I think, isn't that data science 1? And then we've got CIS something else. Or is data science 1 not even a CIS class? I forget. You get the idea here. We've got a bunch of courses here. I do know, what is it, 40? No, I guess I don't know. 421, right, is, this one sounds familiar. Massive data management. Right, does that one ring a bell? My comma down here. And that actually doesn't matter too much. Separate those a little bit. Just be consistent here. So if we want to loop, nope, it doesn't like those. It doesn't like the spaces. Space after the comma, though. So if I wanted to say for class in classes, oops, class is a reserved word, so we'll call this, I don't know, my class, in classes. We can iterate over it. What you're going to get using a for loop dictionary gives you keys. You only get the key value out. So if we were to print my class, I'm only going to get the key value here. So in our case, that's just the course number. Stop and read. Yes, please. There we go. So we get just the key values out here at the bottom. If you wanted the associated values, we would print the dictionary, right, which was classes, key of the variable we're using to store the key. So class's key of my class will give me the associated value back out. Right, so maybe we do that all in one line here. We just print this back out, so we can print each item one at a time. Right, and now we get the key and the value. You just need to be careful when you're looping through here. Now, another really handy use of for loops is doing something a certain number of times. Right, if I know I want to do something 10 times, I could say int, like number equals 0, and while number is less than 10, we'll just say print the number, then number plus equals 1. We could do that, right? We could print 0 to 10. I'm sorry, 0 to 9, right? Because we're going to stop when it equals 10. Stop and rerun. and we'll get our numbers like this. Now, the fine folks at Python are lazy developers, just like the rest of us, in that we don't want to do more work than we need to, right? So we got a shortcut. So our shortcut is this function called range. Range is really cool. So we can say for number in range 10. Now what range does is it gives you one number at a time, up to but not including the number you ask for. So range 10 will give me values. It generates essentially a tuple. It's not exactly a tuple, but for all intents and purposes, we'll call it a tuple of values 0 through 9, right? Not including the value you enter. So then we can just say print number. But I don't have to worry about number plus equals 1. It's just going to do the thing for me, right? So I don't have to initialize anything, and I don't need to update anything. I can just say, hey, for my value in this collection of numbers 0 through 9, let's print the number out. Stop and run, right? And we get out 0 to 9 again. So ranges are fantastic, right? We can range through a given value. Now range, you can do some other things. You can optionally, let's see, so range is an optional start value. Optional start value. So if you don't give it a start value, it's going to assume it's the end value. Here, end value. And you can also give it a step. So if I wanted to say for number in range, if I wanted to start at 10 and go to 100, I'd say 10 to 100. We probably don't actually need to go all the way to 100. That'd be a lot. So how about just the 20? We'll print number. Okay, so I'm going to start at 10. I'm going to go up to but not including 20, and that's the optional step. Here. Give that a run. Stop and run. Okay, and now we get 10 through 19, right? We don't include the 20. Okay, so the step then, if we want to, hey, let's just do even numbers. We could say, hey, I want to step by 2. I want to change to go up by 2 every time instead of going up by 1. Maybe the same if we did our while loop, if we did plus equals 2, it's doing, we're going to go up by 2 every time. Let's stop and run that one. Here we go, and now we get just the even numbers, right? 10, 12, 14, 16, 18. As we go. Okay. The other cool thing you can do with the range is you can go in reverse. So if you want to count down, so from 10 up to but not including 0, stepping -1. Now it's not smart enough to step automatically negative. So if you just say range 5 to 0, like if we just did 10 to 0 and printed off a number, nothing's going to happen. We're not going to get anything after that 18 because it started at 10 and it had nowhere to go to get past 0. It was done. Right? It just stopped. So you need to tell it the negative step here. Enough to figure out negative step automatically. Right? So we need to tell it, yes, I want to go down by 1 each time. And now we're going to get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Actually stop. Yes, please. Here we go. We get counting down with a negative step. So range only works with integers. Right, just for integers. Now the other cool thing we can do with this though, right, if you wanted a loop and you want to loop through a collection here with a for loop because you don't want to have to type out index and manage increasing index every time, we can combine them. So I can say, we'll just do it down here, I guess. We can say for index in range of the length of names. Names at index is equal to names at index dot what is it here? There's a good title. Right, title case. Title casing will capitalize the first letter and not capitalize the rest. Right? Imagine you're like looking at the title of something. Every first letter of a word is capitalized. So title case will do that for us. So we can change the names. And I can print my names list here. Now I'm able to modify them because I'm modifying what's stored in the list. Because I'm looping using the index using the range of the length. So you'll see this all the time. We're going to range through the length of something if you want to change the items in a list. So useful for changing what's in the list. If you don't need to change them, we can just do a regular for loop and take one item at a time. If we do need to change them, we have to do it by index. So this is easier than a while loop with an index. We give this a run, stop and run, stop and run. Now we get them back to title casing, because we use the title operation here, which is really fun. So ranges are fantastic. Right? While loops are great if we don't necessarily know how many times we're going to do something. Right? We can use those sentinel values to say, okay, just keep on going until you give me a particular thing. A for loop will only loop over a collection or a range if we know exactly how many times we're going to do this. So you can always replace a for loop with a while loop, but you can't replace every while loop with a for loop. Right? Does that make sense? For loops can always be replaced by while loops, but not vice versa. Right? Because a for loop is just going over a collection. So we can always iterate over a collection using indexes. Right? But you can't replace a for loop and say, hey, do something as long as something is true as many times as I want. And especially if we don't know how many times it's going to be. Okay? We've actually done, we haven't done nested loops, I'm sorry. So you can put a loop inside of a loop. So if we wanted to print out, we didn't do that? I thought we did. No, we didn't do it. Okay. So it's sort of silly here, but we can do this. So if I wanted to print out every possible time that's going to show up on a clock here, I can say for hour in range 0 to 24, not inclusive. And really, the 0 is optional. Like just saying 24, it knows we're going to start at 0. Okay? And then for minute in range 60, I'll get 0 to 59. And then for second in range 60, in 0 to 59, I want to print, and I want to print a formatted string here. I'm going to print the hour, and I need to format it as, I think it's D2, I think. We'll take a look and see if that actually works. A colon. And, you know, let's just Google it here, because honestly I don't remember, and that's okay. You don't have to remember everything. Python, with an integer format, number of decimals, or number of leading characters, something like that. Let's see. Oh, I didn't take my tab here. Let me bring it down here so you can see what I'm Googling. Format a string as integers with leading values. This one looks popular. Fill, no, I don't want to use fill. Format, okay. Right, in Python 3.5 above. Format I is the value, 05D. Okay, so we're going to say 02 to fill with zeros to at least 2 digits. Hey, Blowfish, how you doing today? So we got hour, we'll do the same with minutes, and we'll do the same with seconds. Oops. Minute, colon, we'll do the same with seconds. So you can put a loop inside of a loop inside of a loop. So the first time this loop runs, hour will be 0. The first time this loop runs, minute will be 0. The first time this loop runs, second will be 0. Then this loop keeps on moving. Hour and minute are still 0. We get now 1 second, 2 seconds, 3 seconds. Once this range is done, this inner loop is done. Then we come back up to this loop. Okay, minute now turns to 1. Right, so I think it's kind of easy to illustrate this sort of way. You can see them all working here. And look at that. So it turns out when you're running code, if you're doing a lot of prints are actually very slow in terms of what the computer can do. A print command takes a long time comparatively. I mean, yeah, spit out a bunch of these here, 1,440 rows, relatively quick. Right? Oh, no, is that, no, that's not even how many rows it was it? Hang on. What's 24? No, that is 1,440, right? 24 times 60 times 60? Oh, no, 86,000. Okay, I'm sorry. 86,000. I was thinking of how many minutes are in a day, right? If we divide that by 60, yeah. Minutes in a day is 1,440 times 60 seconds, 86,000. So we spit out 86,000 rows relatively quick, but it took a little while. So we're going to see, though, hour starts at 0, and it stays at 0 until the next time it comes around. So we get all the seconds up through 59, then we get 1 minute. So this loop will then restart here back from the beginning, this loop will run from beginning to end again. And then minute goes to 2. This loop restarts from beginning to end. We go back to minute is 3, minute is 4, on and on and on. So you can put a loop inside of a loop. So all that ASCII art we were doing, where we said, hey, print out something times the length of a row, we could do with an inner loop if we wanted, but Python gives us a nice little shortcut here. Python's handy. So you can put loops inside of loops. It's called a nested loop or an inner loop. All right, they go through a great example. When we're doing programming, you want to do little bits at a time. This incremental idea. Sort of weird they stick it in the loop section, but they're trying to give you some good programmer tips as you go. If you tackle an entire assignment from start to finish and never run your code, and something doesn't work, it's going to be hard to see what actually went wrong with it and where the problem is. So you want to do a little bit and run it, do a little bit and run it, do a little bit and run it, do a little bit and run it. All right, we got 2 more cool things with loops we're going to look at. There's some special commands that we want that you can use. There's 2 of them. There's one that says break. A break in a loop will immediately stop the loop from running. Game over, loop is done. Continue will say, okay, stop where you are, go back up to the loop header and do the next thing. So in a for loop, it means, okay, go get the next value. In a while loop, it means, okay, go see if this is true again. So if we wanted to only print, say, even numbers, right? We could say if number modulus 2 equals 1, right? Because if you divide out all the 2's and you have a remainder, we can say continue. This stops the current loop and jumps to the header to see if it's true. Right? So this while loop here, so if number mod 2 is 1, we're just going to jump back up to while number is less than 10. Let's give this a look. Where did this one go here? We were printing number, right? I forget where it was. After class and my class. 0. Uh-oh. We broke something. Well, what happened? We're continuing. Where'd it go? I'm losing it already. But we're never changing number plus 1 equals 1 anymore. We did a bad thing. Right, so we got to stop. So we need to do this in the other order. So we need to make sure we're increasing number before we hit the continue block. Because if we continue, this never runs, right? We never print, and we never increase number. Right? Well, that's no good. Okay, maybe we print the number and increase, and then... Oh, no, that's not even going to work, is it? Oh, well, that's just bad. I guess we'd have to add in that plus 1 anyway, then. So continues are ugly. Generally, you'd want to try and avoid it, and to do it, you just do an if-else block. Right? If this thing you want to continue, just have an if-else, where if it's not, then you have the else here. Some people really like them. I find them hard to find. Yeah, if we started at -1, technically, I think the remainder is still 1. I don't actually know what how that works out. What is -1 mod 2? Let's see what Python thinks. -1 mod 2 is +1. Yeah, of course. I don't think negatives behave well with modulus. This is the idle, that Python developer shell. You can just start typing things in here. It's kind of fun. I think we looked at it real briefly when we installed Python, but it's not a development environment. It's not great. It's nice for simple things, so you can just type some Python and go. So continue will jump you back to the loop header, but a break will just completely stop the loop from running. And while that's interesting, you can sort of combine that with another thing about loops, is at the end of a loop, you can include an else, which is kind of funny. The else will run when the loop is done if we did not break. That's all. So you can kind of think, right, like when we look at these while loops, we'd say, hey, while number is less than 10, we'll set number equals 0. While number is less than 10, let's print number. We'll take number plus equals 1. Right, and then we can say else print loop is done. It's essentially like an else if you pretend this is a while or an if statement. So like if this is true, do this. We're saying while this is true, do this. And then when this is no longer true, do my else. So it only runs if you don't break the loop, right? Because if we break the loop, we stopped before this thing became false. So the else isn't going to run, essentially. It's kind of fun. You can stick else's at the end of for loops. You can stick else's at the end of while loops. Totally up to you. There's a couple of cool things you can do with them, but again, they're kind of specialty cases, so just kind of know that it exists, but you don't have to worry too much about it. And you'll practice it in the Zybook as well. All right, and then one other fun thing we can do with looping through things, there's another function we can use which is pretty helpful, right? So we can say, I want to enumerate a list. So what that does for you is we can say, hey, I want two things to come out. I want the index and I want the value in enumerate the names list. And we can print, let's do a formatted string. We'll say value is at index, maybe we'll do index. Let's say index, the index, which is the number here, and then we'll say, here's the value. So we can get all of them here. Oops, I never fixed that loop. Sorry. We broke our loop here with that. So we'll still do number plus equals 1. And again, this is why it's probably easier with an if-else, right? We would just have else print. It's probably a prettier way than using a continue. It's sort of ugly. All right, so index 0 is this, index 1 is here, index 2, 3, 4, all the way through. So enumerate gives you both values out. Kind of a fun little shortcut. Where did it even go? I got too much going on in this section, I'm sorry. So enumerate gives you both. There's both index and value at the same time. So again, if you try and change value, it's not going to change, right? But we could change the names list at the index and do something with it if we wanted. So it's just a shortcut. If you need both the index and the value out at once, you can enumerate, which is kind of fun. Okay, how you folks feeling so far? We're having fun with loops. That's a lot, and we're adding new tools to our toolkit here for solving problems. Maybe you need some more coffee. I forgot to bring my mug up with me. I don't know where I left it. That's a bummer. All right, all good? Awesome. All right, cool. So we got our loops. Let me commit this to GitHub here. So this is our more loops. Commit. And we'll go ahead and push that one out. Awesome. Sorry. Cool. All right, so let's talk about the next project then. We pull this back up. We gotta go back into Canvas. Don't need this one either. All right, next project. So again, we said 2 weeks, right? So that puts us out of the 21st at 3:30 p.m. before class starts. And this one will be worth a little bit more, so we're probably going up to about 15 points when we do this one. Right, so every project, you don't get to forget the stuff we have already done. They're going to get a little bigger and a little bigger, because you just have to use all the things we've already learned. Right, so you're going to submit the URL for the classroom link. Let me set up that classroom GitHub link for you here. And there we go. Make an assignment here. So it'll be a new repository, right? Clone the repository. CIS 1501, 2021. This is project 2. And this will be my Python template. There it goes. And our feedback pull requests, fantastic. So here's the link for it. We're going to please submit relative to the feedback pull request. And so include a, oh, we can't do that. That's fine. Just to the feedback pull request. Hey, Aiden, how you doing today? Happy Thursday. Talk about our next project. So we did the basic retirement calculator, and it wasn't great. It was very simple. Didn't give a lot of details. So we're going to try and expand on that. So we're going to build a new and improved retirement calculator. Okay, so again, we're going to do the same thing with getting their name, user's name, use it in all the prompts. But what's going to be different now, so get initial values for the various, for the money, the mattress, bank savings, bonds, investments, bonds investments. I don't know where the S goes there. We'll do it that way. Stock investments. And then get the current age and desired retirement age. And then for each year until they retire, we're going to do something, right? So we're going to loop for every year until they've retired. We're going to print the current value of each asset type. That's the money under the mattress, the bank savings, the stocks, the bonds. We're going to ask the user if they want to add more money to any of the types. If yes, ask them which type. Then ask how much, and add it to the assets type. So we would say, okay, hey, do you want to add more money this year, now that you're age 35? Yes. Okay, you want to add more money? What account do you want to put it in? Or what type do you want to put it in? You want to put it under the mattress, put it in the bank savings, put it in bonds, put it in stocks? Let them pick. We'll add it to the type. Ask if they have, or if they want to add more, or be all done for that year. Right, so there's a couple ways we can do this sort of interaction. My favorite one is using a loop with that sentinel value. Right, we can say, okay, enter the account type, right, of mattress, bonds, or bank savings, bonds, stocks, or you could give me a different value to mean you're all done adding money. That way we don't have to have different prompts, right? This would be combined the above, asking what type, using a sentinel value. Right, we looked at that idea, hey, give me like a -1 to tell me you're done entering the receipts, because you're not going to have a receipt for a -1 value. Do the same thing with strings. Right? As long as you haven't entered the word stop or something, let's keep on going. Okay, was it this type? Was it this type? Was it this type? Was it this type? Let's add money to it. Okay? Then increase the value of each account type. No change for mattress. What do we say? 2% increase for bank savings. Or no, we said 1% for bank savings, right? For bonds, pick a random value, and let's do 0 to 5%, and increase the value by that. Because technically they can go up and down, or let's do 1 to 5. Let's say you always get at least 1%. It's not necessarily the case, but that's fine. So we can use a random number, right? Randint gives you random values. We looked at using random values. And then for stocks, this is change by, and this stocks can actually go down. So we're going to do a random value. We're going to say negative 10% through 25%. Maybe 25 is a little bit high, but if we look at the like historical S&P 500 returns, we'll see they're not always positive. There's on like a pretty chart here. This one looks like a good chart, right? We'll see. We'll find a good graph here. So, okay, yeah. So, right, up through 2000, things were going up, and then it went down for a couple years. And it went up, and then it went down for a couple years. And it went up, and then going down. So they're not always going to go up, right? That's the risk of investing in the stock market, is things don't always go up. Is this one any good? Let's see. I don't even know what this... Yeah, timely entries and timely exits. If you sell when it's high and you buy when it's low, you make money. Like, okay. Yeah, that's not a strategy, though. So, sure, it can go up, it can go down. There's like a list that you can get, you can download somewhere if you wanted the actual historical returns. We're just going to pick a random number, and they can go up and down for fun. Okay, so for each year, print the current value, ask if they want to add more, which type, and how much, and they can just keep on going. And then we'll increase or decrease, possibly, our values in those investment types. Right, so if you average this out, right, this gives you a range of 30%. So on average, 15% is in the middle. Going from negative 10 up, it's going to give us an average of 5% increase every year. Right, which is going to be higher than the bonds, but not necessarily completely high. You know, let's bump that a little bit. Let's go 10 to like 23. I don't know. No, we'll leave it at 20. That's fine. It's okay. It doesn't have to be actually historically accurate. We're going to do that for each year that we retire. And then once we reach retirement age, display the final balances is total balance and total balance adjusted for inflation. Yeah, oh, that's the current value, present value, I think, present value of the total balance adjusted for inflation. Right, so that's still just a straight arithmetic here. Right, that was the 1.03 power of years. Right, or divide by that. The number of years. Right, so we're going to increase and improve this retirement calculator here because you probably are going to be depositing money every year. Now, the government gives you strong incentives to save money in retirement funds, typically based in stocks. You can also invest in bonds as well. General bank savings, there's not really strong incentives to do that. You can if you work them certain ways, but that's all sorts of weird monetary policy. So generally, the stock market has a strong incentive for new buyers in America to keep on pumping money in. And that helps prices go up, right? If you remember anything about economics and the laws of supply and demand, the more demand there is, generally, the higher the price can get. Because if there's demand for it, we can start increasing prices and people will still buy it. If there's no demand and there's a lot of supply, the price is going to drop because they need to sell all the things that are out there. And again, selling stocks are a little bit, it's kind of funny because we're not like making new products. They're just selling the existing ones. It's just a big resale market, and the people who run the markets get rich off of that, people buying and selling, but that's a whole other story. All right, I'm getting too off in the weeds here. I apologize. Okay, so we'll put together a rubric for this in a little bit. We got 15 points or so. So again, it starts off pretty much the same, but then every year we're going to do this, and then every year we're going to be asking if they want to add more. So we're adding a couple loops into the mix here as we're doing these. Okay, and there's a couple things you can do to make life a little easier too. How we store these particular values, that sorts of things, when we all loop over them. Right? There's different ways of approaching it. So you'll see in 2 weeks how I might go about it. But as long as you get the job done, there's nothing wrong. There's no wrong way. Okay? And we can go from there. Questions, thoughts, or concerns? Let me publish that one here. So we got it out. Close this one down. Close this one down. I don't need to save that. And I think we're good. What do you folks think? So again, the idea with retirement, right? You're going to store more money away every year, but the earlier you put it away, the longer it has to grow with that compound interest, the better off you're going to be. And then we can look at some fun numbers here too, which is fun. So when we finish this up, we'll look at comparison. If you start with a small amount of money every year versus a large amount of money later in your life, you'll actually be better off starting early. So that's our next project here. I'm just kind of improving on our retirement calculator, having a little bit of fun here. And for what it's worth, I mean, it's not the worst estimator in the world. It's probably not super accurate, but it's actually something you can like show people and they can play with and see, oh crap, maybe I'm not saving enough, that sort of thing. You know, these are a little bit funny here, but you know, we could get historical numbers later if we really wanted, or pick some better random ones, but we got lots of options. All right, sounds good. I think that's all we got for today. So when we get to lab on Monday, we'll do some more practice with our while loops, with our for loops, and do some things with that, and we'll keep on going. John, I don't have this published anywhere actually. Like if you wanted to do it yourself, like grab a screenshot real quick or shoot me a message. You can hop in the Discord if you want. Exclaim Discord for the link, and I can send it to you if you'd like. Just send me a message there. All right, should we see if anyone else is around? We can go pester online for fun. Put on a little ending screen here. And see who is out in Twitchland. Yeah, go for it. We'll see you over the Discord then. Let's see, do you guys want to talk about rockets, or do you want to see Obother again? He's still working on his little laser-mounted wall-burning things, or if you want to see someone doing pottery, go hang out there. Rob's chatting. Got a couple people around. It's kind of fun. Yeah, definitely. Thanks for hanging around, John. Let's see. Pottery. All right, we can go hang out there. He's a member of the Knowledge Fellowship, which is a lot of fun. Just a group of people who like sharing their knowledge on Twitch. So however that way, say hi. Folks, take care. And I'll see you Monday in lab then.